So this is a water block for a 2080 Ti Strix by EK. And this water block leaked right up here because of a failure of this O-ring. So what I'm going to do is I'm going to pull it apart and go through the process of replacing the O-rings, cleaning and reassembly. So if we look at the actual O-ring, I've already pulled all the hardware out of it just to make this process quicker. These O-rings are, I can't get it out with that tool. These O-rings are in pretty good condition. It's hard to see, but you can see if you rotate them, the diameter appears the same all the way around. Now, the main O-ring, the largest one, has a significant deformity. So this O-ring right here and get that out of there. Again, it's going to be a little hard to see, but if we look at the profile of it and rotate it, it looks distinctly fatter one way than the other, and that's a permanent deforming of this O-ring. So what's ended up happening is that it is so smushed that when those two contact surfaces mate, there's not enough pressure between the O-ring and the mating surfaces for it to actually create a seal, which is why it leaked right here. Now, unfortunately for me, I was an idiot and installed this block on a card that I had just repaired for testing, and in the process of benching it is when I found the leak and it dripped into the PCI Express slot, frying the card. So I'm still waiting on new components to arrive for that to see if the damage was permanent or not, but it shows the damage that a faulty block can do. So what we're going to do for the purpose of replacing this is I have some O-ring cord, and it comes in a bunch of different sizes along with a tool and contact cement for replacing them. And what we're going to do is we're going to find the length of this O-ring, cut a section off of the new stock, and then actually run it through the channel, get the final length, trim it, and make the seal. So I had measured this O-ring, and it was a little difficult to measure because it, like I said, it's deformed. But I had guessed, based off my calipers, that we were somewhere in the neighborhood of 1.5 millimeters, and this is 1.5 millimeter cord, and we can see that the diameters, if we can focus, are a little bit off. That'll probably be easier to see once this is cut. All right, so when we look at the two ends, we're a little bit smaller on this one. So my concern with that is that if I replace this O-ring, this O-ring might also have to be replaced. And the reason is that we're dealing with two flat surfaces. Well, one flat surface and then one grooved mating surface. So if we have two spots that it seals, and we've got an O-ring that's this size over here, and an O-ring that is this size over here, there's an unequal gap and there's going to be unequal pressures. So this gap might not have enough force applied to the O-ring for it to actually fit to the space properly. So we might end up with either a flexing of the block or just a straight leak. So what I'm going to do is I'm going to replace this one first, pressure test it with the old O-ring for this slot, which is fine, it's in great condition. And then if If we have a leak over here after that, then I'll go ahead and I'll replace this one. So my 1.5 millimeter cord, I'm going to get a rough length and because of the bends and twists in the old O-ring, I'm going to go maybe a quarter to 1/2 an inch beyond it and cut it there. So now that can go away, this can go away, and we're going to take this O-ring material and feed it through the channel. So here we are. I probably should have started this end in the middle of a straight run so I could get these a little bit closer without having to fight with this bend. I think it's going to be close enough. So what we're going to do is we're going to just mark that with a little cut. Pull it back out. Find our cut. And I'm going to finish it off here in this block to try and keep it as straight as I can. So this is the closest size block for this. So what we're going to do is we're going to apply a little bit of this contact adhesive to one end of the O-ring and then apply it in that block until it sets up. If I can get my adhesive open. All right. I don't know if you noticed some of the white stuff that was on this cord. It was just a little bit of adhesive from the tape that bound the end of all the cord bundles together. So we're just going to apply a little bit of adhesive to one of these sides. Just a very tiny bit. Now this is a place that you can really mess up, because if you apply too much adhesive, then you're going to get a poor seal on your O-ring. And I wish I had a little bit smaller guide for the size O-ring, just because it doesn't really fit in the slot really well. So I feel like the end is not necessarily mating up the best. Yeah, that wasn't the best contact. So we're going to sit here and hold this for 30 seconds. It looks pretty straightforward, pretty well in line. So we're going to sit here and hold this for the 30 seconds of immediate cure time. And then we can see about installing it. So one thing about this cord, when you're actually mating the ends up, you want to make sure that you don't twist it, or else the cord is not going to lay flat when you start installing it in your application. All right, so with our joint made, we're going to start installing this in the block. All right, so now that we've got our new O-ring lined up in its groove, we'll be installing it, or reassembling it here shortly. One thing to talk about with cleaning blocks while you have them open, when you're cleaning the metal portions, rubbing alcohol works great. It doesn't leave any residues. It evaporates off without any issue. But it's not something that you want to use to clean the acrylic. So acrylic surfaces, acrylic poly, like a plexiglass, polycarbonate, alcohol can make these cloud up. So what I used to clean it was a little bit of WD-40, which left no residue and a fairly clear surface. There are a little bit of surface scratches in this block. Some across here, very, very faint scratches, and then some on the back side. And I'm not entirely sure where these scratches came from. They weren't from me. So this block must have been opened beforehand. All right, so we've got this O-ring in place. We'll install this O-ring to check to see its fitment. Now we're going to have to keep a close eye on each of these corners as we install the block to make sure that it doesn't come out from any corner and give us a poor seal in that area. Okay, so that's ready to install. I'm going to talk about the hardware real quick. So the hardware was originally very rusted, corroded. Obvious that it had leaked at some point before and had been leaking for a while, long enough for the hardware to oxidize fairly heavily. These are M3 and M4 screws. I want to say that they're They're both 6 millimeters in length. But all I've done for them is soak them in WD-40 for a little while. I'm just going to give them a wipe off before I install it in the block. The portions of the block that these are going in is not going to be hurt by the WD-40 if there's a little bit of residue on there. Honestly, I don't know that it would hurt being inside the loop. You know, if WD-40 were to get in the water loop, I don't know that it would be a problem, but I'm just trying to avoid having that issue. You can see where that still has a little bit, maybe you can see, there's still a little bit of rust down in these threads. But that's not going to be seen. What I'm going for is protecting the threads and not having them seize up at some point. All right, we're ready to start installing. So M4 screws are all of your big holes around the block here. Oh, I missed a few in my tray. Okay. And then these O-rings need to go in. Now, these two O-rings look very similar in size, but they're not. One's a little bit bigger than the other. If you try to take this one up here and install it up here, you'll notice that we can't. It's too small. It wants to pop back out, and if an O-ring is stretched like that, it's not going to have the best sealing characteristic. Now, one of the good things about the O-rings between the block and the cold plate is that you can see their position. You can see if it has popped out of the groove at anywhere. Once we place this top cover on, it's aluminum. We're not going to be able to, or I'm sorry, it's coated copper, so we're not going to be able to see those O-rings. So we need to make sure that they're in place and try to drop this down as vertically as possible without making a whole lot of sliding movement between the plate and the block. So those are going to take all of these smaller screws, the M3 screws, Now as these go in, we're just going to snug all of them. And when I say snug, I mean I'm just running them until I feel the slightest bit of resistance in the threads. I want to get them all just reasonably in to that point before I start increasing the pressure on it. What we don't want to do is we don't want to cause a blowout of the O-ring because we're applying uneven pressure to it. Now the same thing over here. Okay. Now I'm going in a random pattern here so that I can try and keep the tension distributed evenly around the block. And it's the same concept as in tightening lug nuts on your car, if you're familiar with that. You don't tighten them going around in a circle, you go in a star pattern. It's hard to go in a perfect star pattern when you've got such a odd array of bolts, an odd pattern. But as long as you're generally applying, you know, a random pattern going back and forth across the sections of the car, then it shouldn't be an issue. Now this screw is a little stripped out. It gave me a lot of trouble removing it. So I ended up using a Torx bit to get in and get it removed. That's a neat trick. If you've got an Allen head that strips out, a lot of times you can get a slightly larger Torx bit and get good grip with that. So this point, I'm getting about to the end of where I'm going to torque these down to. So I'm going to go all the way around and just check my torques just to make sure that all of them are about where I want them to be. I see that's stripped out to an Allen for tightness, but that Torx turned it perfectly. All right, now we're at the point that we can pressure test. So what we're gonna do is we're gonna plug 3 out of the 4 holes. And this 4th hole, I'm going to use a pressure tester, and we're going to check and see if it has any leak to pressure over time. This is what I should have done with the card to start with, but I was in a little bit of a rush, so I didn't, and it cost me. So this is Thermaltake's leak down tester, and you can see we have a green range of 0.5 to 1 bar on pressure. So we're going to inflate to some point between those two, and you see that we're still leaking down. Now this is where we can figure out where our leak is coming, and I'll show you that trick here now. All right, so what I'm going to do is I'm going to apply a little mix of soap and water around each of the points that it could theoretically be leaking. And we're going to look to see if we make bubbles anywhere. So we're going to test our front points here. Now we already expected that we might have an issue with leaks around our other O-ring over on this side. So that's a possibility, but I'm going to test everywhere first. The soap and water is not going to hurt the card or the block as long as we clean it up well when we're done. So no leaks there. So now we're going to apply a little bit along this seal or this seam. So our 2 biggest candidates for the leak are that O-ring that we were talking about for the reasons that we were talking about it, and then the joint that we made. So those are the 2 places we want to test. Really test first to see, do we have something there, or is that just my finger? You can also listen and see if you can hear it from where you're injecting. So in here is one of our spots. And around here. So I can still hear, I can hear it better flipped on this side. Alright, so we see where our leak is. And it's in roughly the same spot that it was leaking before, but from the other side. So, with that being said, it might not actually be a leak in the original gasket that I thought it was. It might be a leak in one of the gaskets on the actual block connection itself. That's a little bit more annoying to get to because this RTX label will have to come off, and then we'll take the screws out and investigate the condition of those O-rings. Those O-rings are actually constructed a little bit differently, and I've seen before where they're flat, and I've seen before where the stock mounting from the factory has compressed them to one side or the other, so there's very little material actually making a seal. So we will get that apart and then take a look at that. All right, so these are those seals. And you can kind of see on this edge how that's mushroomed out. And a little bit on this side as well. Now also, looking at the profile, these should sit slightly proud of the surface. But while this side looks like it does a little bit, this side does not. So I'm gonna have to get these out, and I don't think I have an O-ring material that is small enough to remake this one. So I'm probably gonna have to get some, because I think this is closer to like a 1mm O-ring. So I'm gonna check that out. If I have it, I'll go ahead and make it, and if not, I'll continue this once I get the new material. So I've got to take the block back apart anyways, because I forgot to install this little piece when I was putting it back together the first time. Now you'll notice there's a slight curve to it. So when it's placed the correct way down, it's got a little spring from the middle. What you don't want is to install it backwards to where it rocks from the ends. So I'm gonna go ahead and throw that in. So again, like I said, the correct way to install this, the spring in the middle. We're going to put this, there's a little groove that you can see here, and this fits right in this groove. So when it is installed, the pressure between the two blocks is going to hold it in place. Now, there is a slightly different profile between the two sides. And I had it backwards there for a second, but if you look closely at the spring, we're a little more squared on this end and a little bit more rounded on this end. And it becomes evident when you install it whether it matches up or not. So that's the correct placement of it. Now we will make sure that our O-ring is back down in place again. And go ahead and reinstall our block. Unfortunately, I lost the audio for this last section of the video, so I'll have to voice over the rest. So I was actually able to find the correct O-rings from the EK Waterblock website, which they're more common for the FC blocks, which makes sense. Those come on more models, so why you can find those, but you can't find the actual O-ring kits for the blocks themselves. The only bad thing with ordering those O-rings was that shipping was a little on the high side. I'll probably end up getting a little bit of the 1mm O-ring cord just to have it on hand in case I need it in the future. So the plan is going to be that we're going to go ahead and reassemble the block and pressure test it and see if we have any new leaks. When you're tightening these bolts back down, try to go a little in on each one. Don't tighten one up all the way, and that's going to keep O-rings from shooting out the side and not making good contact. So now it's time to put the plugs back in, the leak tester back in, and then pressurize it and see what happens. With the leak down tester, what our goal is to pump it up somewhere between 0.5 and 1 bar, which is indicated by the green. And when I did, what I was seeing was that it was leaking down, but pretty slowly this time. After finding the slow leak, I did try the soapy water trick again, but wasn't able to figure out where it was coming from. So I had another trick in mind. So what I've done here is I filled the sink up to where it's high enough to cover the water block in completely, and I'm going to inflate the pressure tester, and we're going to see where the bubbles are coming from. And as soon as I start applying a little bit, you can see that it's coming from that screw hole. Unfortunately, this isn't going to have a good ending, and we'll take a look at that here in a second. So if we look closely at this bolt hole, we can see the line that bridges from the side of the water channel to that hole, and that's a crack in the acrylic. Sorry it's having trouble focusing, but I couldn't get it to focus any better than that. But having that crack there means that when the block is under pressure, which it is under air and it is underwater, it's enough to allow water to pass through that crack and come out. In the end, it was disappointing that I wasn't able to get this fixed, but at least it wasn't because of my O-ring replacement. It was because of an actual defect in the block. So I went ahead and threw it all back together. I'm not really sure what I'm going to do with it at this point. I might take a stab at replicating the acrylic block, but we'll have to see. But thanks for watching.